Hello everyone, I'm P.P.Mahajan from All India Sri Shivaji Memorial Society's Institute of Information Technology, Department of Electrical Engineering. In this video lecture, we'll be taking a look at the addressing modes of PIC18 microcontroller. So before going to the addressing modes, we'll take a look at what is called as an opcode. So opcode is an operation code, and it is an operation to be performed on a data. An operand is a data on which the operation is performed. The definition of addressing mode is the addressing mode can be defined as sorry, the various ways of accessing data, and these are the different addressing modes. So we'll take a look at each one of them. The first is register direct addressing mode. In this addressing mode, the address of the operand is a part of instruction. So we've taken an example, move WF 0x01, 0. So the address of operand, that is the address of data, is being given in the instruction, and that address is, in this case, it is 001. So in this instruction, the address to which the contents of working register are copied is 001. Next addressing mode is immediate addressing mode. In this addressing mode, the data is a part of instruction. Okay, so data is the operand. So example is move LW0x09. So 09H is a data which is a part of instruction. So this is immediate addressing mode. Inherent addressing mode, the address of the operand is not specified in the instruction. It is implied in the opcode field. It means that you don't have to give the address in the instruction. So if you consider an example, add LW some data, and then the data by default will be added with contents of working register. We did not specify the address of working register. So this is inherent addressing mode. Next is register indirect addressing mode. In this addressing mode, the address of the operand is stored in a register. So there is a pointer register which is used in this addressing mode, and the registers which are used as a pointer registers in PIC microcontroller are called as file select registers. So there are three file select registers: file select register 0, file select register 1, and file select register 2. So one of these registers will hold the address of the data. So suppose the address of data, suppose this is 11 is the address of data. Sorry, 11 is the data, and the address of data is 100. So this address will be held by a register FSR 0, 1, or 2. So to load this this address in file select register, the instruction is LFSR 0x100. So file select register 0, 1, and 2, all these are 12-bit registers. Now there are special function registers which are associated with the file select register, and there are 5 of them. INDF uh, is one register, post INC, pre INC, post DECM plus W. So we'll concentrate on the first register, which is INDF. N has a value of 0 or 1 or 2 because there are 3 file select registers. So what INDF 0 does, we'll understand it through a small program. So suppose we need to store the contents of working register to a memory location pointed by FSR 0. So this is an internal RAM which is shown. So for this statement, what we'll do is we'll be using say file select register 0. So we want to store the contents of working register to a memory location pointed by FSR 0. So we'll be loading FSR 0 by some contents of internal RAM address, which is say 100. So for that instruction, for that to happen, we will be using an instruction LFSR0 0x100. So this instruction will load 100H into file select register 0. Next, we have written an instruction move LW0x03. This will load 03 into working register. And now if I want to copy contents of working register to a memory location pointed by file select register, then I need to use an instruction move WF INDF 0, 0. Okay, so in the previous slide, so we have seen that for file select register 0, there are n number of SFRs which are associated with file select register 0. One of them is INDF 0. So if you want to copy or if you want to use a memory location pointed by FSR 0, which is 100 in this case, in the instructions you need to use SFR INDF 0. So what this means is that move the contents of working register to, when we write INDF 0, it will move it to a memory location pointed by FSR 0, which is in this case 100. So 03H will be copied to a memory location 100. So initially the contents were 1, 1. So now it will become 03. So this is a register indirect addressing mode. And next addressing mode is bit direct addressing mode. In this addressing mode, individual bits of a register can be accessed. So the instructions such as bit set file 0x00, 7, 0 will set the 7th bit of memory location 000. So if individual bits are used, then the addressing mode is called as bit addressing mode. So these were the addressing modes of PIC18 microcontroller. Thank you.